In this lecture, we're gonna talk about a special case of broken access control vulnerabilities that is called Idor. Idor is short for Insecure Direct Object Reference, and even though the name is pretty long, it's actually a very simple vulnerability or a bug. It happens when the application directly accesses user data without verification based on user input. Therefore, by manipulating the user input, we will be able to directly retrieve data that does not belong to us. And because we are able to see and possibly modify data that does not belong to us, IDORs fall under broken access control, because that is the definition of broken access control vulnerabilities. We use the word object in here to refer to any type of data. For example, it could be files that belong to another user. It could be images that belong to another user. Now, obviously, we're talking about private images. So if it's a profile picture, for example, in Facebook that is visible to everybody and you're able to access it as another user, that is not a broken access control or an IDOR, because that is the design of the application. It's supposed to show you that picture. But assume you're able to access private pictures that shouldn't be available to you or to other users, then that would be a valid IDOR vulnerability. Objects could also refer to database records. So in the previous example, we were able to modify this value in here. So this is user input, and we were able to retrieve the API key and other information by simply modifying this value in here. So this could possibly be a blind IDOR. I'm saying blind because we don't have access to the web application and we're not sure that this is an IDOR. We are sure that we were able to discover information and we're sure that it's a broken access control, but we're not sure what is the programming mistake that is causing this. But assuming that the web application is directly communicating with the database based on the user input that we're giving it in here, then that means it is an IDOR because it is directly accessing database records associated with this ID using our user input. So by simply modifying this ID right here, even though we're logged in as John Wick, if we replace this ID by 1, which is James Bond's ID, we will be able to retrieve James Bond's information, because the web application is communicating with the database directly and retrieving the record that is associated with ID number 1, and therefore it'll get us James Bond's information. Now, as mentioned earlier, IDORs are not limited to database records. You could use them to directly access documents and images that are supposed to be private, that do not belong to us. So an example in here, assuming that the web application directly loads the profile picture from a path that is called imagesjames.jpg, and assuming that this picture is private, it shouldn't be visible to all users. As another user, or without logging in, if you're able to open up your browser and put the direct path to this image in your URL bar, and the image is actually loading without authentication and without checking if you actually own this image, then you're able to directly access this object, and therefore this is an IDOR vulnerability, Insecure Direct Object Reference. Let me show you an example which will make it even easier to understand. I'm going to include the link of this example in the resources as usual, and we have a simple website in here similar to the ones that we've been testing, and as usual you should be testing every single functionality, but I know that the bug is in the live chat, and as usual you want to go ahead and use this chat as a normal user. So let's just say hello. We're going to click on send to send the message. You get a response. We're going to say how are you, send the message again. You get another response. So we know that this feature works and we know how it should work in general. And we have another button that we haven't pressed, which is the view transcript. And when you press it, it's going to download a text file for you. And if we open this text file, you'll see the content of your conversation with this bot. Also notice the name of this text file is 2.txt. And if we continue chatting to this bot, so let's say test this time, and then download the transcript again, you'll notice now the number is 3. And if we click it, again, we're going to get an updated version of our conversation with this bot. Now that we tested the normal functionality of this bot, let's go ahead and intercept the requests, because as you can see, when we're clicking on send and view transcript, nothing is really being appended in here because everything is actually being submitted as a post request, as you're going to see in a second. Therefore, there isn't really much for us to test other than the data that we input in here. So you should test this text box for all the vulnerabilities that you will learn in the future. But for now, let's turn on the interceptor and let's send another message. So let's say another test. And as you can see, we can see the message that is being sent. We're just going to forward it again. You can see the typing when the bot is typing, forward. And we have the answer as well, which is pretty offensive. But anyway, now that our interceptor is on, let's also click on view transcript to download our transcript. And as you can see, for that to work, this button is simply just sending an empty message to download the transcript, and the web application is translating that as the user wants to download the transcript. So anyway, we're going to forward this. And as you can see now, a post request is being sent to this path. And when a post request is sent to this path, it's gonna trigger another GET request, but this time it is to a text file. So as you can see, this time the number is 4.txt. So the first file that we downloaded was 2, the second was 3, and the third is 4.txt. And if we forward this request again, our browser is gonna download this file right here. Now, this is a direct object reference to this file, to the file that is number 4.txt. But this is not a bug because this file does belong to us. But if you're able to download this file as another user or without logging in, then that will add the insecure part to the direct object reference, which will make it an access control bug because the web application should check if you actually are authorized to downloading this file. Now we can also play with this. So as I mentioned earlier, the first file was number 2, the second file was number 3, and the third file was number 4. But we actually never downloaded a file that was called 1.txt. So let's see if there was another user that had a chat before us and got the file that was called 1.txt. So we modified that to 1 in here, just in the plain text. We're going to click on forward, and we're going to modify it again here to number 1. And let's forward it again. And perfect. As you can see, now we downloaded a file that is called 1.txt. So we successfully managed to download a file that belongs to another user. Now, regardless of the content of this file, right now we have an insecure direct object reference because we are able to download a file that does not belong to us, that belongs to another user. And we were able to know the path of this file by simply looking at the requests in here. So in a secure web application, the web application should have checked, do we own this file? And only display it to us if we actually own it. But now we're able to get someone else's file. And if I open this file, you'll actually see this file actually contains a password. But even if it didn't, like I said, regardless of the content of the file, you have discovered an Idor vulnerability because you're able to access files directly using their file path. And therefore, you should definitely include this in your pentest report or submit a bug if you are participating in a bug bounty program.